My name is Li Ping. I work for Databricks. I used to work for Microsoft, and I realized I am undercover on the Fabric side today. So please be nice. I do have my Microsoft jacket with me as well, just in case anyone wants to punch me in the face. Um, so I'm here to talk about Power BI on Databricks best practices. I know a lot of people here come from a Power BI background, Fabric background. You're probably using Synapse Fabric, some Databricks in your data platform. This is to offer you an architectural pattern to say Power BI can connect to Databricks SQL and visualize the data you have in Delta table. And these are the performance, security, access control, networking considerations for best practices. Cool. My name is Li Ping. If you want to connect with me on LinkedIn, I do a lot of content creation on three things: Databricks, Power BI, as well as career in data, like how to interview at different companies and what different roles look like, how to switch roles, and so on and so forth. So for this specific topic, Power BI on Databricks best practice, we're going to break it apart into what to do in Power BI. Now, a lot of people think I'm going to hook Power BI on top of Databricks, or I'm going to hook Power BI on top of Synapse. It should just magically work. No, you need to performance tune Power BI, you need to performance tune Databricks, and you need to performance tune for the things that happening in between Power BI and Databricks. This is what we're going to go through today. So on the Power BI bit, apologies for the engineers in the room. I'm going to be slightly boring and just talk about data modeling for a little bit. You want to think about imports and direct query. You want to think about using definitely star schema. If you're using pure Databricks with no Power BI, if anyone heard of something called Lakeview dashboard or AIBI dashboards, in a pure Databricks world, Databricks is built for things like star schema, but you can also do super wide fat tables. That's completely fine. A big wide table will work just fine in Databricks. But Power BI is why it's different. Power BI loves star schema because star schema gives you the capability to do two things: the aggregations and filters. The dim tables let you to do filters, and the fact tables let you do aggregations. This is why Power BI works best with star schema. You can have big fact tables in your silver layer, in your bronze layer. Once it hits your gold layer or your curated layer, however you want to call it, once that's the layer that you're bringing into Power BI, you want to make sure that's star schema. You want to consider doing things like composite models, aggregations, hybrid tables. So use the better of both worlds. Import mode, direct query can coexist in a data model, can coexist in a single table as well. I know someone's going to have a question later on about what about direct click. We can take that in the end. Referential integrity. This is a toggle in the relationship management UI in the model view of Power BI. You want to toggle that on if you know that the relationship between the two tables are inner joins. This is just because inner joins operates a lot faster. This is not necessarily just Databricks. Inner joins operates a lot faster in any SQL engine. Query folding. Again, Power BI traditionally is built for visualization. So if you have very, very heavy transformation logic, you don't want to have all of them sit in DAX. You want to build views, materialized views, potentially like gold tables to let Databricks handle a lot of that transformation logic and pump that result into Power BI. So Power BI's job is easier because in Databricks, you're not limited to the compute power of your P1, P2, P3, or F64, F128, 256. So you want to get that transformation logic as much as possible done in Databricks. You want to use efficient DAX calculations. This is the same with saying do not have all of your transformation logic in Databricks, in Power BI. Inefficient DAX calculations can cost you a lot of performance. I had a customer back in Microsoft. They have millions of rows in a table, and they're like, why is it slow? It's only millions of rows. Shouldn't be slow. And then they had a rank X on it. Of course, it's slow because it's operating row by row. So you want to look at your DAX calculations and use more efficient calculations if you can. This is super, super important because Databricks offer you a lot of scalability in terms of scaling up and scaling out. And Power BI lets you control that concurrency. So these 4 settings within Power BI will let you change per query and per connection how many concurrencies runs between Power BI and Databricks. And you want to play around with this and match this with what your setup in Databricks is, right? So if you had a classic SQL warehouse in Databricks and you don't have any kind of like clusters, you have like minimum 1, maximum 1, no auto scaling, no nothing, then this won't help you. But if you have auto scaling set up, if you have serverless in Databricks, this can help you a lot when you have a lot of users that's querying your Power BI report, especially in situations like direct query mode, or it can speed up your import mode data refresh quite a lot if you have partitioned your Power BI data set properly as well. Reduce the number of visuals on a page. Anyone that uses Power BI knows this, so I'm not going to go into this. Essentially, every visual will send down at least 1 query, sometimes 7, because a lot of these queries are metadata queries down to the data source. And you want to minimize these queries, which that's sent down to data source on the direct query mode, because it's going to slow down your performance and add to the load on concurrency. So for direct query mode, the maximum amount of visuals you should have in a page is 7, no more than 7 if you're doing direct query mode. For import mode, knock yourself out, should be fine. To apply and clear 4 slicers, basically 4 slicers and filters. This is the same with query reduction settings. 4 slicers filters, what Power BI does is before you select everything, every time you interact with a slicer or every time you interact with a filter, Power BI will render what the query is and send it down to Databricks. And let's say you're selecting the month, and then before you can select the country, Power BI is already sending, the whole world and generate down to Databricks. This query result is not useful for you, and you don't want to pay for that compute. So what you want to do is to have a apply all button for your slicers and do apply all query reduction setting for your filters, so that after you select all the parameters for your filters or slicers, and then you get Power BI to send down 1 set of query down to Databricks. And this is just to save you money on compute, on intermediate step on the query visualization. And this is just goes without saying, use the latest version of Power BI Desktop. I wanted to call out, is there any Mac users in the world, or everybody's Microsoft, like hardcore Surface? No? Okay, never mind. If you have friends and family that's using a Mac, basically, Databricks pushed out a feature called Publish to Power BI directly, which means you don't no longer need desktop. You can publish a data set or semantic model directly from Power BI Workspace, from Databricks Workspace to Power BI Workspace. So that way you can get around with not having to connect to desktop, pumping all your tables and then publish to Power BI workspace. Everything can be done directly in the web from Databricks workspace to Power BI workspace. If you have a MacBook, that's great because you no longer need a VM in order to work with Power BI. The second thing is parameterization, super important for CI/CD. If you are using, I don't know, deployment pipeline, tabular editor, you want to parameterize your connection strings. So as you promote your code through different environments, your SQL warehouse connection strings should change as per your catalog in Databricks as well. So the intersection between Power BI and Databricks is two things. It's access control and network security. First is access control. Access control start with authentication. Authentication is basically Power BI goes to Databricks and tell Databricks who you are. And this is basically, there's three different ways to do this. Username and password, the personal access token, and OAuth. There's considerations on each. So username and password does not support MFA or 2FA. So if your organization have multi-factor authentication turned on, you have to like press Opta or like AAD, like get a text message to verify this is you. Username and passwords cannot be used. You can use personal access token. It's a great way to verify who you are. But as per any security practice, Databricks' best practices do not have a personal access token that never expires. Right? The default is 90 days. You can have 180 days, 365 days, but you want to have an expiration date for your personal access token. You don't want someone to have your access to your data forever and ever. And when you do have personal access token expire, you need a notebook to actually do the key rotation in in Power BI. If anyone's interested in this method, I got a notebook in Databricks. You can just like schedule it, and it calls the Power BI API and do the key rotation for you. Should probably put that on YouTube at some point. But the third method, probably everybody will use that, is OAuth. Since everybody here is Azure, what you're using is actually AAD. And no, it's on AWS, right? Yeah. We'll skip that bit. Basically, right now, if you are using Databricks on AWS, you can also use AAD pass-through if your like identity provider is Azure Active Directory. I'll fly through this. I'm assuming everybody knows about this. I made this slide for my Databricks coworkers because they don't know how Power BI works. People author a Power BI report. You will log in as your personal user. Like Power BI will know who you are. And depending on the methods that you're using to authenticate, Power BI will send your identity down to the Databricks SQL warehouse. And SQL warehouse will go check with Unity catalog and see what you have access to, and then go fetch the data from Delta Lake, get you the result back. And you do your development, you publish your semantic model to Power BI service. Once you do that, you need to go and edit data source credentials and set up a credential for Power BI to either do data refresh on the import mode or do direct query on. For that, typically for import mode, you want to set up something like a service account. A service account, that's an account that doesn't belong to anyone in the organization. So if someone leaves, it doesn't impact your refresh. Or you can do that on a direct query as well. Alternatively, you can use AAD pass-through. So Power BI will send down the identity of your end user to Databricks, and you can set up access control for all of the end users in Unity catalog. So essentially, it's these three patterns. The first pattern is if you have any, I do mean any, import component. That means composites, aggregations, hybrid tables, import mode, any imported components in your semantic model, you will need a service account to talk to the SQL warehouse. And your access control will need to be set up in Power BI if you want to do granular level access control. This is because as far as SQL warehouse is concerned, it's the service accounts that's talking to the Databricks instance, and it will give Power BI what the service account has access to. So if you want to say Ian has access to UK, I have access to US, you need to do that access control in Power BI. The second pattern is the same. You can do the exact same thing in direct query mode. The third pattern, though, if you're using the third pattern, you can actually set up the access control for everybody, that's the end users in Unity Catalog. You will need to toggle on let end user report viewers pass down their identity to the data source in Power BI UI when you set up the data source credentials. But if you're using that, you don't need access control in Power BI. You do need everything in direct query mode. And then Power BI will send down whoever's viewing the report identity to Databricks. Unity Catalog will check if that end user have access to ABC, and then send back the results. For that, Unity Catalog can check whether this person have access to the table or not. It will check row level security. So does this person have access to this row? It will do column masking. So if you have credit card information, I don't know, phone numbers, email address, you can mask those. It will all carry through to Power BI, as well as dynamic views. So if you have a dynamic views in Databricks, that will access control, that access control will get reflected in Power BI as well. Networking security. So some people come to me and say, we try to tune everything in Power BI, we try to tune in everything in Databricks, it's still very slow. Chances are the problem is your networking security. You turned on either front-end private link in your Databricks workspace or IP access list. Both of these says your computer, you're accessing the Databricks workspace, your computer, or any OOBDs, ODBC, JDBC connections that includes Power BI that's talking to Databricks need to be in a private network. And Power BI is a SaaS solution. It cannot be put in a private network. This is why you need a gateway. And the difference between these two is the front-end private link dictates your laptop that's accessing Databricks workspace or any kind of API, ODBC connection need to be in a private network. And the traffic between that private network and Databricks instance will travel through Azure Backbone. Whereas IP access list says whoever is accessing Databricks need to be in this set IP range, but the traffic between the laptop or the ODBC connection and Databricks will travel over public internet. That's the difference between private link and IP access list. But in order to get Power BI to talk to Databricks, if you have these two turned on, you need either a VNet gateway, which is a managed solution, requires you to have Power BI Premium, but the hardware of VNet gateway is not scalable. It does have auto scaling within what those hardware offers, but the actual hardware, as it says on the Microsoft documentation, it's not scalable. If you want scalability, if you want load balancing, if you want more control, over the performance of your gateway, you want to do something called on-prem gateway. It basically is a gateway installed on a VM, and you can set it up. It does need to be managed by you, but it also can be scaled. Depending on your traffic and how you performance tune your Power BI as well as Databricks, networking security is oftentimes the bottleneck for performance in most of the cases that I see. Databricks considerations. I don't know how many people are familiar with Databricks, since I'm on the wrong side of the fence today, but I will try to go as you know, I don't know, if there's anything unclear, please ask as well. Anyways, so these are the Databricks best practices in terms of storage and compute that's specific to the Power BI integration. First, what you want to do is to use serverless SQL warehouse instead of the all-purpose compute. The all-purpose compute is what people use Databricks notebooks to, right? So they're writing code in the notebook, they're attaching the notebook to a all-purpose compute. Traditionally, before Databricks put out SQL warehouse like 2.5 years ago, people used all-purpose compute for connecting to Power BI. But SQL Warehouse is so much better in terms of performance because it's made for BI workload, and you want to use SQL Warehouse to connect to Power BI. And you want to use serverless because it's cheaper, it helps you to do auto scaling, and it will be a lot better than like the all-purpose compute or classic or pro tier of SQL Warehouse. And you want to utilize something called query history in Databricks UI. Essentially, if you want to do the performance tuning of your Delta tables yourself, query history will tell you like what columns you want to Z-order your table by, or what column you want to like liquid cluster your Delta table by. And basically tells you the query patterns or the usage patterns of end users, specifically those queries that's coming from Power BI. So you can Z-order your tables, you can optimize your tables, you can liquid cluster your tables based on the query patterns. And you also want to use system tables. System tables is the public preview new feature. It gives you a few things. It gives you billing. So instead of going to Azure portal and trying to figure out which part of your cost is Databricks, all of your Databricks cost is written as Delta tables in system tables. So you can query it using SQL. You can build dashboards on top. We build a cost template using Power BI. And on top of system tables, so you can do cost analysis, root cost analysis, cross-charge. We're doing that talk in Data Scotland, if anyone's going up there in September. And system tables also gives you like your cloud infrastructure costs in the future. So instead of just Databricks cost and this magic unit called BBU, you will also see what your Azure cost is in system tables coming soon. And there will be jobs, tasks, so you can identify long-running jobs, long-running tasks, who's used all my compute, who's cost me too much money, who's on the naughty list. All of these things are on system tables that you can query. Optimize. So Delta tables can be optimized. Now, if you are on Unity Catalog and your tables are managed tables in Unity Catalog, you have a few features that are available to you. You can do predictive optimization. So Databricks will manage the optimization of those managed tables for you. You can do auto liquid clustering. So based on your query patterns, Databricks will go and like do liquid clustering based on the best like column to liquid cluster by. But you can also do these commands yourself if your table is not on Unity Catalog and not managed tables. Databricks is just trying to do these for you behind the scenes, so you don't have to do a lot of heavy lifting yourself. If you're using SQL Warehouse, start with a medium warehouse because it's t-shirt size. Start with a medium warehouse, and you can scale up or scale down, scale out if you need to for most of your workload. This is the same thing I used to say in Microsoft. Start with a P1. If it's not good enough, then upgrade to P2. Same thing. Start with a medium and see where you go from there. You scale up if your data is higher volume, if your query is more complex. You scale out if there's more end users querying your Databricks, especially on direct query mode. You want to definitely turn on auto scaling if you have very, how do you say, like periodic, like traffic hours, rush hours for your Power BI traffic. Auto scaling is a great option for you, so you don't have to manage the scaling option of your compute yourself. And you want to check predicate push down. So again, all the logic, if you can, push them down to Databricks. Databricks is made to process a lot of data. And so it will be a lot faster than just having everything in Power Query or DAX. Use materialized views if you can. Use Lakehouse Federation if you can. So I think 2-3 years ago, Power BI came out with a feature. It used to be called direct query on Power BI dataset. Essentially, you can bring in different data sources on top of a Power BI dataset as a data source, and then bring additional sources like Excel. At that time, it was really exciting because everybody loved to bring their own Excel into the Power BI dataset. But it's not a very scalable solution. So if you want to do a lot of joins of different data sources, try the feature called Lakehouse Federation in Databricks, because it can federate data in from things like Oracle, Snowflake, Redshift, what have you. Most important thing is you don't have to give end users the access to those federated sources, because all of this is actually managed by Unity Catalog. So like these federated data sources are external catalogs in Unity Catalog. You just give people access to the catalog. It's a lot easier than managing the access control for 7 different systems for your end users. You can just manage all of that within Unity Catalog. Last thing is don't do very wide data types in Databricks. You can. It doesn't affect Databricks performance all that much. It does affect Power BI performance if your model size is too big. So try to use narrow data types if you can. This is super important. You want to isolate your Databricks SQL warehouse. Don't use a single medium-sized warehouse for your entire company. Unless your company's like 20 people, then you'll be fine. But you want to use like different SQL warehouses for different departments, potentially, or different teams. This is really good for things like if you have a rogue analyst that wake up in the morning and just decide to like refresh Power BI every 3 seconds, and it will like, you know, throttle your traffic if you don't have auto scaling set up. And it's good for cross-charging if you come from a bigger organization that everybody likes to charge other people fake money. This cross-charging really works if you have different SQL warehouses set up, and also helps you to right-size different SQL warehouses for different type of workloads and different teams. Certain teams have more people than other teams. Certain teams have more complex queries or bigger data versus other teams. So it helps you to right-size your SQL warehouse as well. A few things I want to call out, relatively new features. So you have entity relationship diagrams now in Databricks, as long as you have defined the foreign keys and primary keys in Databricks. You can go to the entity relationship diagram and see how your tables look together. And this can be a preview of what you pump into Power BI. And again, publish to Power BI. No more VMs if you're on a Mac. I'm the only one that's excited about this, clearly. I've broken way too many VMs. But yeah, this is a great feature for CI/CD as well. So this feature will offer API support very soon. Once the API support for this comes out, you'll have an end-to-end DevOps experience from Databricks to Power BI without worrying about desktop development mode. Here are some resources. I realize that these are hyperlinks and you don't have the deck. Hit me up on LinkedIn. I can send you all of these in one go. Yeah, cool. That's it. Really, really quickly. So if you are a Databricks user and your end users like, we want to consume your Databricks data in Excel, Power BI is a great way to do this. Right, get your Power BI a semantic model to talk to Databricks and then to analyze in Excel in Power BI. We don't have a Excel connector that's free of charge right now. A third-party vendor built a Excel add-on that you can connect to Databricks with. We're campaigning for Databricks to build a native connector. But for now, you can either do an ODBC connection from Excel to Databricks or going through Power BI, which is right now probably the most hassle-free way to serve your Excel users. That's the only thing I wanted to cover. Thank you. Any questions? No questions. Oh, okay. Yeah, go ahead.
Just wonder if there's any best practice when you use a native query. I'm on Databricks project now. And sometimes it's really hard. You need to wait the data engineering. So I do the SQL myself in Databricks and I bring in Power BI as a native query and hard. Any concerns or anything? Because I've been doing that for so long, but it works.
Yes.
Sometimes that is a temporary solution and stays there forever because
yeah. Like depends on the shape of native query and if that native query is used elsewhere, sometimes it's better to transform that into materialized views in Databricks.
Yeah, so that's what I do. So I have the deal. So and then I go multiple, I do my SQL, so I need to go down instead of doing Power Queries first.
Yeah.
It's quicker.
Yeah.
And then I think the performance is better, and then I just bring it.
So if you're happy with the native query performance, you can stay there. If you're unhappy, bring it to materialized views can potentially, because it's pre-computed, your performance will be better. And also materialized views, well, I don't know if anyone heard of Enzyme, which is probably a Databricks project that that's not many people know about. So things like materialized views, traditionally, you have to recompute the entire table. Things like sum, right? It's very easy to do it incrementally because let's say the first 100 rows, the sum is this much. And if we insert 2 more rows, you can just calculate the sum of 2 additional rows and add it to the top of the first 100 rows. That's how you incrementally calculate a sum. Things like average, traditionally, most of the engines will do a recompute because you can't incrementally calculate average. But with something like Enzyme, which materialized views has, you can do a lot of incremental operations. Average being an example, because what Enzyme will do in a materialized view is to break down average into a sum operation and a count operation. Both as the sum operation and the count operation can be incremental. So your previous result of your 100 rows, the sum and the counts, plus the 2 more rows, would do an incremental operation of the 2 additional rows, the sum and the count, and then just do an additional divide. So materialized views is typically a lot faster than your normal views, or just a SQL query. And that does depend on how complex your query is. It might be worthwhile to look into.
Yeah, but to the materialized view, all need the read access, right?
Yeah, you need read access to
Well, not
that.
read, sorry, right, access, because I only have read access, so that's the part I developed, they won't let me go there and build deals, so
Yeah,
that's why I use the native query.
Fair enough, yeah.
Okay.
Yep. If you have a few queries that's often used, you can compile them together, get them to create the materialized views.
Yeah,
It depends on whether you're happy with the performance, then you don't need it. Yeah.
It's like an accepted best practice that native query is supposedly a bad idea because it breaks query folding.
Yeah.
But there's a query folding hint that you can add.
And then you add it in.
But the Databricks connector adds that hint automatically. So actually, Databricks native queries don't break query folding.
So it has to be DBR 8.3 plus. So there's a in the connector. This is not exposed to the end user, but in the connector there's a
Who's using 8.3?
Huh?
Who's using 8.3?
I have a customer that's using 6.7. Not to name names, but the point is basically use native query equals to is automatically added after 8.3, so you don't have to worry about that. Yeah.
And the other thing is just get your data engineers to do a better job.
Well, you know reality.
I know.
Someone else had a question.
Yeah, so it's a slightly, it's an indirectly related question. But just wanted to get what your take is on Excel and sort of where it stands in industry. Because anyone who's not like a technical data person will use Excel. And how sort of, Excel is very loose.
Yeah.
In the sense that anyone can do anything.
Yeah.
Whereas like the new systems, they're more streamlined, but they have to be like better managed, more well thought out. And particularly from like a cultural point of view of someone who isn't used to that way of thinking. So yeah, just wondering, like, have you had like personal challenges with getting companies to adopt kind of like a more streamlined way of thinking about data and pushing them out of like an Excel kind of mindset? And yeah, do you think Excel's here to stay? Like how?
So Excel's got 4 billion users in the world. If I say Excel will die, those 4 billion people are not going anywhere, unfortunately. Exactly. So there will, like, despite how much my fellow the engineers hate Excel, Excel is here to stay. There will always be Excel users that use Excel as a database and an ETL tool and draw Pikachu if they want within Excel. I've seen that, unfortunately. That said, right, like your data offered to Excel, whether that's from Databricks or Power BI, should be a data product. It should be clean. It should be trustworthy. Like the end users that's using Excel to consume the data shouldn't need to do any more like cleaning. The data quality should be there. They should trust the data enough to say this is up to date. This is clean. I can trust whoever makes this, table. I can just consume it. I might need to filter it. I might need to build my own little bar chart on it within Excel, but like they shouldn't need to clean the data from there. That said, Power BI's got Copilot, Databricks has got Genie. So this has got quite popular with a lot of executives. There used to be that the CFOs will go into Excel and check their own numbers. Like Databricks Genie or Power BI Copilot right now is English as the SDK. So you can go to a Genie space and ask questions about your data. It will, like, what's my profit this year to date? It will give you the answer, give you the data. You can get Genie to build a visualization for you. It gives you the SQL query behind it as well. So it's like, so you can check the SQL if you know SQL, so you know you can trust it and everything. Because it's LLM built on top of structured data, you can train Genie's behavior if you have, customer specific, like domain specific language. Like MCU stands for Marvel Cinematic Universe, that kind of things. You can train Genie's behavior to your organizational language and like specific domain expertise. So like we see a lot of C-level, director level decision makers take on Genie quite happily, just because they no longer need to do pivot tables.
That's really interesting. Thank you.